In this video, we're going to be going over electrons and the atom, and this is our part 4 video inside of our chemistry chapter. And specifically inside of this video, we're going to do a quick recap of J.J. Thomson, and we're also going to look at some experiments he did, and also we're going to look at some experiments that Rutherford did as well. So let's get started with this video. So first thing we're going to do is a quick recap of what J.J. Thomson did to a conclusion. And we talked more about J.J. Thomson in our previous part 3 video, so feel free to watch that video out as well. So let's get started with J.J. Thomson to a conclusion. So he noticed that electrons are much less massive than atoms, and he did this because he did a gas discharge tube test. As you can see here, this is the test he did. So this was a significant observation because that implied that atoms must also contain other components to account for their mass. So you notice that there should be extra things instead of atoms because electrons have really less mass. And furthermore, it also notes that electrons appear to be present in all samples of matter, a realization that led J.J. Thomson to conclude that every atom must contain electrons. So J.J. Thomson was the one that said that every single atom in the world contains of electrons. And another thing that he said was about positive charges. So since electrons are negatively charged and matter usually has no overall charge, so it became clear that atoms must also contain a source of positive charge to balance out the negative charge of the electrons. So this was another thing that J.J. Thomson concluded while he was doing his experiment. And furthermore, there was also some uncertainty. So despite these groundbreaking discoveries, the source and arrangement of the positive charge within atoms were not clear at this point in time. So J.J. Thomson wasn't able to fully understand more about the protons that was inside of atoms. So the problem was that J.J. Thomson knew all about this, but he didn't really know where the protons would actually be. So all the positive charges, he didn't really know about that. So this was J.J. Thomson's model, and it's called the Plum-Pudding Model. So this is how he imagined that the atom was actually like. So according to this model, there was an atom that was thought to be a pudding of positive charge with plums of negative electrons embedded in it. So this was his model, and basically inside of his model, so he said that there was one circle, as you can see here in the image, that one big circle would be considered as the positive charge, and inside of this big circle he said that there was plums, and these plums are called electrons. So J.J. Thomson thought that there was a big overall circle, and inside of it there was electrons, as he called this plum. So this was J.J. Thomson's Plum-Pudding Model, and as of current days we know that this wasn't true, but this is what J.J. Thomson believed was the right version of an atom. And furthermore, inside of the Plum-Pudding Model, positive and negative charges. So since electrons are negatively charged and atoms are electrically neutral, Thomson proposed that there must be a background of positive charge to balance the electron's negative charge. And that's when he decided to create the Plum-Pudding Model like that. And furthermore, also for the mass of atom, the model implied that most of the mass of the atom came from the positively charged pudding, as electrons were known to have less mass. So J.J. Thomson already knew that electrons had less mass, so he believed that everything else was the positive charge. So that's why he said that there was a big circle and that whole thing was positive charged, because he believed that it had a lot more mass compared to the electrons. So this summarizes J.J. Thomson's model, which was the Plum-Pudding Model. And now I'm going to talk about someone else who came up with more information on atoms, and his name was Rutherford. So we're going to look at a famous experiment that he did, which was the gold foil experiment. So Rutherford's model was based on his famous gold foil experiment, in which alpha particles were fired at a thin sheet of gold foil. So here, if we look at the right, this is Rutherford's gold foil experiment. So there's a beam of alpha particles that were fired at this tin foil, and we're going to explain what happened in the coming slides. So what he noticed was that most of the particles passed straight through the tinfoil, but some were also deflected at large angles. So you can see here that through this alpha particle, most of the light went directly through and hit the edge here and the back, but you can also see that some got deflected frontwards, some got deflected backwards in different angles. So this was something that Rutherford noticed. He noticed that it was being flown into different directions and also different angles. And the reason why they actually bounced back into different directions is because the light, this beam of light, which is the alpha particles, what it did was that it hit the nucleus of an actual atom. And once it hits the nucleus, then it starts to deflect. So once it hit this nucleus, then it would deflect there, some would deflect here, and in so many different directions. So that's the thing that Rutherford noticed. So with this gold foil experiment, he came up with the nuclear model. So Rutherford concluded that most of the mass and all the positive charge of an atom must be concentrated in a very small central nucleus. So then Rutherford came up with something like this. So he said that there was something in the middle called the nucleus, and he found this out because of the alpha particles. Once they hit the nucleus, then it would bounce off. So this was Rutherford's new type of model that he created based on the experiment of the gold foil experiment. So furthermore, Rutherford also came up with electron orbits. So in Rutherford's model, electron orbit the nucleus at a distance similar to planets orbiting the sun, and the vast majority of the atom's volume is empty space. So this is exactly how his model looked like on the right. So it looked like they were going in elliptical orbits, like the nucleus was the sun, and all these were the planets, and majority of the atom was covered with vacuum space. So now we're going to go over a conclusion for Rutherford. So most passed through. So inside of his test, most of the beam of light passed through. So the majority of the alpha particles passed straight through the foil, indicating that most of the atom's volume is empty. And some deflected, and this is because this was unexpected and also indicated that there must be something small, dense, and also positively charged at the center of an atom. And the implications was that electrons must then orbit this nucleus at relatively large distances. So this concludes everything that Rutherford did to help on with the theory of atoms. So now we're going to go over the conclusion of this video. We specifically covered over Rutherford's experiments and also a review of J.J. Thomson. And in our next video, we're going to dive into the further development of the atomic theory. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next chemistry video.